This video is about transformations of curves. Now at GCSE you covered transformation of curves and nothing new has been added to the A-level course, so it's exactly what you covered for your GCSE. It is very important that you learn this table so that you can describe mathematically what is happening and you can also put it in words, and it's important that you can write the general equations. So if we start with a curve y equals f of x, so that just means that y is some function of x. It could be a quadratic, cubic, doesn't matter basically. And we can then transform that in different ways, and the table details each of those. So the first one, y equals f of x plus or minus a. So if you have your original function and you add or subtract something away from that function, what it means is it's a translation parallel to the y-axis. So if it tells you to add on something, you move up the y-axis. If it tells you to take away, you move down. So if it was plus 2, I would move my whole graph 2 units up. If it was minus 2, I would move my whole graph 2 units down. And mathematically, we use vector notation. So it's a translation of 0a. Remember, 0 is the x, so we're not doing anything with x coordinates. It's not moving left or right, but it's moving up or down depending on what this value is. Second type of transformation again is another translation, so another movement, but this time parallel to the x-axis. So if the x has changed, then it's a translation parallel to x-axis. However, we need to be careful with this. If it's x plus a, it doesn't mean that we move the graph right. It actually means we move left. So when we're dealing with the x-axis, positive is left and negative is right. Okay, as well as translations, we have to do stretches, and we know that something's a stretch when we see a function being multiplied. So if we are multiplying the whole function by a value, the stretch is parallel to the y-axis by a scale factor of whatever a is. So if it was 2 f of x, then we'd be stretching it by a scale factor of 2. Now to do this, all we have to do is multiply the y values by a and keep the x unchanged. So y-axis stretch, we change the y values. If it's an x-axis stretch, then it's the x term specifically gets multiplied. It's not the whole function, it is just the x term, so it's within the bracket. However, the scale factor in this case is not a, but it's in fact 1 over a. So if you had y equals f of 2x, the scale factor would be a half. And in this case, if it's to do with the x-axis, we multiply the x values by a, or by the scale factor, sorry, 1 over a, or we divide by a. But the y values remain unchanged. So we've had translations, we've had stretches, and the last two are reflections. So if your original function is multiplied by minus 1, it's a reflection parallel to the x-axis. So normal rules of reflections from Key Stage 3 apply to this. If the x term gets changed to a minus x, so it's y equals f of minus x, it's a reflection parallel to the y-axis. So make sure that you learn this table off by heart and you can recognize these 6 different types of transformations. Let's have a look at a few examples to try and put these into practice. My advice would be have the table on the previous page sitting out in front of you as you try these for the first time to make sure you know exactly what you're doing. So what we've been given is the graph of y equals x squared, so just our basic quadratic, and we have to perform a couple of transformations. Now the first one, we want to draw y equals x minus 2 all squared. So it's asking us to do a translation. So if we put this back into our normal term, if you look at your table, so if we start with y equals f of x, well what's happened is that x has changed to an x minus 2. So it's within the bracket, it's the x value itself has changed within the function. So it's a translation parallel to the x-axis, and remember negative 2 means we are moving it to the right 2, as the right is the negative direction. So all we do is take our curve and move all the x coordinates 2 units right. So instead of being 0, 0, the turning point moves to 2, 0. Instead of this coordinate here being at minus 2, 4, it will move across to 0, 4. And this coordinate here at 2, 4 will move across to be 4, 4. So all the x coordinates have moved 2 units to the right. In our second example, then our x term has been replaced by an x plus 3 and we're squaring the whole thing. So what this means is it's a translation 3 units left. So basically we just pick our graph up and we move everything 3 units over to the left. So the turning point at 0, 0 needs to go 3 over. So it goes to minus 3, 0. In our third example, you can see that we're no longer adding or subtracting. So we've moved away from translations. But what has happened is that the original function f of x has been changed to f of 2x all squared. So the x term has been replaced by a 2x. So because it's the x term that's been multiplied, it's inside the bracket, it's an x-axis stretch. So that means we're going to multiply the x coordinates. The scale factor, however, is not 2, it is reciprocal. The scale factor is a half. So we're going to take each of the x coordinates, divide them by a half, and draw the new curve. Oh, sorry. If we have a look then at the original, I know it's quite difficult to see. Let's zoom in a bit. The axis isn't great. So because it's an x-axis stretch, it's only the x coordinates change. So 0, 0 will stay at 0. Let's pick a point that was originally at 2, 4. So the y coordinate will stay at 4, but the x coordinate must be halved, so it moves to 1, 4. And same on the other side, the point that was at minus 2, 4, a half of minus 2 is minus 1, so it moves to minus 1, 4. So the graph has been squeezed in. For the last example of this video, you can see that x has been divided by 2, which is really the same thing as multiplying by a half. So it could have been given to us as y equals a half x all squared. So the x term itself has been multiplied or divided, which means it's a stretch parallel to the x-axis, and the scale factor in this case is going to be 2. So remember, it's the reciprocal. So what we need to do, because it's related to the x-axis, we are going to divide all of our x coordinates by 2 to get the new coordinates and sketch a graph. Let me just delete this writing before we do. Again, I'm going to zoom in, make it a wee bit easier for us to see. So let's pick a few points. The original's in black and the red's the answer that I've sketched on. So 0, 0 stays at 0, 0. The coordinate that was at 2, 4. Well, we need to double the x. So instead of being at minus 2, 4, y stays at 4, but x needs to go to minus 4, so we've minus 4, 4. The coordinate was at 2, 4 here. Well, we need to double the x coordinate of 2 to make it a 4. The y stays the same, so it goes to 4, 4. So the graph has been pulled outwards. So for x-axis stretches, if it's a fraction in the equation, it means that the graph gets pulled outwards. However, if it is an integer or a whole number, if it's a whole number that you're multiplying x by, the graph actually gets squeezed in. So the x-axis ones are the trickier ones. The y-axis ones are much more straightforward, and that's what we're going to move on to look at in the next few slides.